For this video, we're going to be looking at scientific notation. A quick definition for scientific notation is it's an abbreviation for a very large or very small number. As a refresher, the general structure of a number that's been written in scientific notation is going to look like the following: m times 10 raised to the n power. So let's talk about what those variables are representing. M is your coefficient, and its value is going to be something that's either equal to 1, or it can go all the way up to, but not include 10. Some examples would be 1, 1.2, 5.4, 6.17, 9.8, all the way up to, say, 9.999. So what I want to note here is that I'm usually only going up to, at most, 3 decimal places. After that, it could be kind of viewed as a little excessive. Most numbers that are written in scientific notation maybe use only around 2 or 3 decimal places. N represents the exponent of the scientific notation, and it's going to be an integer value, so it could be positive. So 1, 2, 3, and so on. So no decimal values or anything like that. It could be equivalent to 0, or the exponent could be a negative integer, so -1, -2, -3, and so on. Please note that the exponent is going to be negative when we work with a small number, specifically a number that is less than 1. The exponent is going to be positive when we work with a large number. In other words, a number that's going to be either equal to 1 or usually greater than 1. The base of the exponent is always going to be 10, and that's because we work with a decimal system. So an example of this would be, think about when you count numbers. You reset essentially every time when you get to the 10th value. So let's actually go ahead and put this into practice. So we're going to convert a number to scientific notation. Let's start off with an example of a very large number. So specifically, let's look at the estimated number of cells in the human body. The number that we're going to work with is 37,200,000,000,000. To begin, we want to locate where the decimal point is on this number. And it would just be hanging out all the way over on the right side. From here, we want to move the decimal place until we get a coefficient value, again, that's either equal to 1 or up to, but not including 10. So here we go. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I stop here, notice I'm not quite right. Right now I have 37.2. And again, that is not between 1 and 10. So I'm going to move this one more time, and that's going to give me 3.72. That does fit in between 1 and 10. So I'm going to note that I moved the decimal point 13 times. From here, I'm ready to write out my scientific notation, and that's going to give me my coefficient of 3.72 times 10 raised to the 13th power. For example 2, we're going to look at the wavelength of green light, which is actually going to be measured in meters. So just as before, we want to locate our decimal point, and in this case, it's a lot easier since it's staring right back at us. From here, we want to move that decimal point, counting how many spaces we move in order to create that coefficient. Just as a reminder, your coefficient is going to be between 1 and 10. So let's go ahead and begin. We're going to go 1, 2, 3, 4, 5, 6. And again, if we stop here, we're coming up a little bit short because this would leave us with 0.55, and 0.55 is not in between those values of 1 and 10. So I'm going to move this one more time, and that gives me 5.5. That does fit within this compounding inequality that I have over on the right-hand side. Specifically, 1 is less than or equal to 5.5, and 5.5 is less than 10. That's a true statement all the way through. So I'm going to note that I moved this 7 spaces. From here, we can go ahead and actually write our solution. So our coefficient is 5.5 times always a base of 10, and we're going to raise this to the -7 power. And again, in this case, it's -7 because we're working with a very small number, so a value that is less than 1, or in other words, a decimal value. Another way to look at this would be which direction you moved the decimal point. So in example 1, since you moved the decimal to the left, we are going to have a positive exponent value. When we moved the decimal over to the right, we were creating a negative exponent value. Let's review the steps. 1, we want to locate the decimal point on the number. 2, we want to move the decimal point to create a coefficient that is between 1 and 10. Specifically, we want that coefficient to either be equal to 1 or it can go up to, but not include, 10. 3, we want to count how many spaces and the direction the decimal was moved. This determines the value and the sign of the exponent. So if you moved that decimal point to the left, you're going to have a positive exponent. Moved it to the right, you'll get a negative exponent. Also, remember, you can just look at the number that you started off with. So if you have a number that is 1 or bigger, then the exponent that you will have will be positive. If you started off with a decimal value, you will have a negative exponent. And finally, number 4, we want to write the number in scientific notation. So you've created all those parts. The coefficient, you already know the base will be 10, and then the exponent value, you just want to assemble it. Now it's your turn. Go ahead and take some time, pause the video, and try to convert these two numbers into scientific notation. As a note, if you need to, please round the coefficient of your solution to the hundredths place, or in other words, the second decimal place. When you're ready, press play. So for our first one, we have 783 millionths. We're going to locate where that decimal point is, and we end up moving it 5 spaces to the right. So our final solution here will be 7 1/83 hundredths times 10 to the negative 5th power. For our second number, 42,687,513 and 9/10, again, we're going to locate that decimal point, and we're going to move it to create our coefficient. In this case, we end up moving that decimal point 7 spaces to the left, and we have a lot of numbers that trail after that decimal point. So again, here is where I'm going to note that here's my second decimal point. I see that there's an 8 next to it, so that's going to tell me to round the 6 up to a 7. So this is why I'm also using approximation symbols, because I did a little bit of rounding for my final answer to get 4 27 hundredths times 10 to the 7th power. Again, just as a reminder, when we present a number in scientific notation, we're usually presenting the coefficient so that it has around 2 or 3 decimal values. And finally, just as a little extra treat for everyone, we're going to convert a number in scientific notation back to its standard form. So say that we start off with 8 237 thousandths times 10 to the 9th. Here's what we're going to do in order to convert it back into its standard form. So the first thing I'm going to do is I'm going to drop down my coefficient. The next thing that I'm going to do is I'm going to note the exponent. Now, since this exponent is a positive number, that tells me that I should be creating a really big number. So that means I'm going to move my decimal point over to the right. So I'm going to start off with my decimal point, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have all these empty spaces. What do I fill them with? I'm sure that you can recall from maybe past classes, we're just going to fill these in with zeros. So now that we're done, we're ready to present our final solution. So this will become 8,237,000,000, and then we're done. Likewise, say we want to convert this value, 2 3/10 times 10 to the negative 4th. So again, looking at that number, I know I'm going to have a decimal value because of that negative exponent. So again, to begin, we're going to drop down our coefficient of 2 3/10. I'm now going to locate my decimal. There it is. And then I'm also going to highlight how many times I need to move it. So before, since I was creating a very large number, I moved the decimal over to the right. Now that I'm creating a very small number, I want to move that decimal over to the left. So again, I'm going to go 1, 2, 3, 4. I'm just going to highlight where that decimal point lands. And I'm going to fill in any empty spaces with zeros. So my final answer will be 23 hundred thousandths. Notice that I did put a 0 out in front of the decimal point. You don't need to do that. It's just my preferred way of presenting my final answer. All right, we are all done.